So we left off here on the three components of experiment, which is variables, constants, and control. And I'm going to cover those three components today. Three components of step 4, which is experimenting in the scientific method. So variables. There's 2 types of variables in an experiment. Anybody know what they are? 2 variables. So that's the other part.
Independent.
Good. We've got an independent variable. An independent variable is what you test. It's what you manipulate. Anybody know what that word flashing in there? It's what you do to the experiment. So test, manipulate, or give me other words that define independent variable. Test, manipulate.
Experiment.
That's what you're doing. I heard it. No?
Change.
Change. Good. You alter, change, test, manipulate. I would write down all those words because sometimes you never know which word they're going to choose on the test, right? Test, manipulate, alter, change. That change, and I put that word in the middle because an independent variable is what you change, and that change causes something to happen. And that something that happened is called the what? What variable? Dependent. It needs you to do something in order for that change to occur. It's what you measure. So we manipulate. Let's go back to, what's your name again? Next to Nick? Nathaniel. Remember Nathaniel couldn't find the class? And then he said, if I walk upstairs to the 200s, I can maybe try to find a room. So he walked upstairs. If I walk upstairs, walking upstairs is the independent variable, then I will find the room. Find the room is the dependent variable. It's what happened because he walked upstairs.
It's like cause and effect, but science.
Let's try to raise our hand before we blurt out, okay? So that we can keep some organization. So, it is, if you create a really good hypothesis, and you want to write this down. And you could go back to this page and say this. Now that we know something, we can go back here. If you create a good hypothesis, after the word if is your independent variable. If I do this, I'm doing something, I'm adding something, I'm manipulating something, then my dependent variable will happen. Hopefully, right? Because sometimes we're not right. But we're thinking if I do this, then this will happen. Now, so again, a good hypothesis will have the independent variable listed right after. If I do this, so this is what I'm going to do, then this will happen. This is the outcome. Okay? And that way when you get questions on the test, if you can recognize the hypothesis, you'll be able to recognize the independent variable and the dependent variable. You just have to remember which one is which, okay? Yes. How many variables should be tested at a time in a good experiment? One. And you are Melissa, correct? Yeah. Good job, Melissa. Shout out to Melissa. I'm sorry. If you test more than one thing, you will never know what caused that outcome to happen. So you only want to test one variable. If your variable doesn't give you the desired outcome, you try another one, okay? I have some examples coming up. Yes. So now we're going to talk about controls and constants. So we only want to test one variable. We want to set up an experiment where we have one variable. But we also want to use controls and constants, and we're going to talk about the difference. So the control group, anybody know what that's like? It's one that just doesn't have, it's not that it has nothing to do with all the others, it doesn't have what? It doesn't have the change that we manipulate. What do we call that change that we manipulate? I'm not recording. Oh, yeah, I am. What do we call the change that we manipulate? Nope. Independent variable. So in the control group, the variable being tested is missing. And the variable that we test is called the independent variable. So the independent variable is missing. Constants are things that we try to keep the same throughout the experiment. It has nothing to do with what we're testing. It has to do with everything else. So I want to keep everything else the same. And I know that's hard to understand right now, but I'm going to give you some examples so that we can help understand each of these components. I am going to always give you examples of experiments. This is an example of an experiment. The observation is, I saw this plant and I thought, does water affect plant growth? Obviously, we know the answer to that, right? But we're pretending we don't. Does water affect plant growth is my question. But I'm giving you these two scenarios, pot A, or group A, if you want to call it, and group B. And I want to ask you a question right off the bat. Do you think this is a good experiment? Sophia, right? Sabrina?
Yes, because you have variables, controls, and constants.
Okay, she says yes, because we have variables, controls, and constants. Anybody disagree with Sophia? Sabrina? All right, so let's talk about it. Nobody disagrees with her. What's my independent variable? Say it, Nick. The water. I am going to test if water affects plant growth, right? So I added water to pot B, so that makes pot A or group A my what?
Control.
My control group. But now let's look at pot B and let's look at pot A and tell me if everything else in that experiment remained constant. So we're back to the question. Pot A is my control because it's missing the independent variable. Pot B has the independent variable, which is water. Are pot A and pot B the same in every other aspect, which means I've isolated my variable and eliminated constants? And Nick said no, because what does pot B have?
Water.
That we wanted to have. That's the independent variable. What does pot B have?
I think that's the heat. Is that heat?
That's heat or light. If I want to test if water makes a plant grow only, I would need to add this light to both pots, A and pot B. So now everything is constant. I have the same pot, I have the same plant, I have light on both plants, and the only thing I'm testing is water because that's the only extra thing I added. So if we're going to stick to this slide and I ask you, is this a good experiment? We're going to say no. Okay? The reason why this is not a good experiment is because I have two variables. So yes, you're right in your question. I have light and water as a variable, but I only can test one variable at a time. So if I want to make this a good experiment, I go here and I add, let me do this again. I add light to both. And now what would my hypothesis be? Who could come up with that? Perfect. If I add water to a plant, you don't even have to identify which one it is, then it will grow faster than a plant without water. Yes? Let's make this fit on the page. So if I add water to a plant, then it will grow faster. What's my independent variable? Everybody should say this out loud.
Water.
Water. What's my dependent variable? No.
Light.
If I add water to a plant, then it will grow. What is happening to the plant is your dependent variable. What is affected because of this change? The effect should be growth. Does that mean the plant is going to grow faster? No, I'm testing it out, and I'm pretty sure that's going to happen, right? Okay, unless if it's a plant that doesn't need water. All right, moving on. Another experiment. All right. I've got pot A. It's receiving water. There's a plant. There's a pot, and it's in a box. I've got pot B. It's receiving water. There's a plant. It's the same plant. It's in a box, and there's light. So what am I testing now? What do you think? Let's go in order. The first step of the scientific method is what? Say it. Observe and question. So I am going to be observing what? Who could tell me now? Good. Does light affect plant growth? Really, my observation is, if I want to go like super small, I wonder what affects plant growth, right? I'm going back to the years before we knew what plants did. And we're testing what makes a plant grow, okay? And then I'm going to do what? Second step. Say it out loud. Second step. The one you're going to miss on the test. Good.
Research.
I'm going to look for information on plant growth. I'm going to look and look and look and look. And then I'm going to create an educated guess, which is exactly what he said. I hypothesis. Let's make exactly what he said into an if-then statement. Who could do that?
If I add water to the plant, it
We got water on.
the light.
Okay, good. If I add, keep going.
If I add light to the plant, it will grow.
Good. So I'm saying everything so you could see my constants. My variable, let's take all this out, guys, right here. Take out water, soil, and let's just leave light so you don't get confused. Light is my independent variable. What's my dependent variable? Grow. Again, the only thing is I changed the independent variable. So light is my independent variable. My dependent variable is growth. Which group is my control? A. Why is A my control? Because according to the definition of a control group, it's missing the independent variable. Can pot A grow?
Yeah.
Yes. Maybe it doesn't need light, and my experiment is a big disaster, okay? But I am testing, does light make plants grow? What are my constants?
The water, the box, and the plant.
Good job. The water, the type of plant, the size of the plant, the amount of water, the amount of soil, and the size of the pot. All of those things, it's not just a pot and a plant. It's my plants need to be the same size to start, because if not, or at least I should measure, right? I need to make sure they're in the same box with the same amount of air conditioning. I could keep going and going and going. Those are constants.